Hello everyone, Gaza Mutkarsh, and I welcome you all to this session on data automation with Python scripts. So guys, let's have a look at the agenda for this session. The agenda for this session includes automating file input output through a use case. Alright, so what are the different steps that we are going to take? We'll be creating different functions. First one to create synthetic data, alright, for synthetic data generation. The second function would be to process, analyze, and even clean that data, individual files, if I'm creating n number of individual files, because the objective is to automate file input and output, right? Then we'll be creating a function to automate the file input output processing. So on the synthetic data generation, once we have the synthetic data, right, we'll be, let's say, creating a function to process those files, and to apply those processing steps on those files, we'll be writing the automation script. Till the previous session, guys, we have discussed how to write data transformation scripts using repeatable workflows. So guys, let's switch to the Jupyter screen. So guys, currently we are in the Jupyter screen, right? So the topic is automating file input output. So let's understand the use case. So over here we'll be, let's say, automating stock price file processing. So let's understand the problem statement first. The problem statement that we have over here is that you receive daily CSV files from multiple stock exchanges with data like the data obtained is ticker, then we have open, close, high, low, high and low prices, and then we have the volume. So what is ticker? Ticker essentially means, let's say, the stock. Ticker is the name of the stock that we are observing, right? It's the name of the stock. Then what is open? Open is the opening price, right? The opening price, the price at which it was opened as far as Indian stock market timing is concerned. Let's say the opening price at 9:15. Then close is the closing price at 3:30. High is the highest value that the stock price that this ticker has achieved on a particular day. Then low is, let's say, the minimum value that this ticker has gone for a particular day. So these are the four values that we are observing for maybe one or multiple tickers. And then we have the volume. Volume indicates the total number of shares traded per day. So guys, I hope these let's say 4 characteristics are clear to everyone. Maybe I can write this in separate lines so that just to give you a context, this is the opening stock price at let's say on a particular day. All right, then close is the closing stock price. This is the closing. All right, this is the closing stock price on a particular day. Then we have high. High represents, let's say, highest stock price, or instead of highest, let me write maximum stock price for a particular day, right? On a particular day, on a particular date. In fact, this is for each different dates. And likewise for low, it would be the minimum for a particular date. This is low, this is the minimum. And then what is volume representing? Volume is simply representing, simply representing the total volume of shares traded for that stock on a particular date. All right, so these are the 4 terms that we should be familiar with when we are dealing with, let's say, handling stock market data. So ticker is the name of the stock, all right, and open is the opening stock price, close is the closing stock price on a particular day. So this is particular, right? Then volume is the total volume of shares traded for that stock on a particular date. And what are our requirements? So this is the synthetic data that we'll be creating. All right, this is the synthetic data that we are going to create. And what are the requirements, or what is the objective? Automatically read all the files in an input folder. So there may be 3 files, there may be 4 files, there may be n number of files. Then clean missing value / outlier, if at all there are any. compute metrics such as daily return, volatility, there can be n number of other metrics, and save the cleansed and the transformed files to an output folder. These are our requirements. So this entire, let's say, will be, let's say, populating the data synthetically, and then we'll be storing them in a folder. And then this, let's say, data cleaning, data processing, and computing the metrics part. This is the data cleaning, processing, and transformation part. This transformation has to be applied to each and every file present in the input folder. This is where automation comes into picture. So we'll be writing the function first to, let's say, data for applying data cleansing, transformation, and cleaning. And once this function has been created using the OS library, right, we'll be, let's say, writing the automation script or the function to apply this data cleaning and transformation functions to all the files present in the input folder. This is the benefit of, let's say, implementing automation using Python scripts. So guys, first things first, we need to import the libraries. So over here, as you can see, I'm importing NumPy. Then I'm importing pandas, I'm importing OS. All right, and then from datetime library, datetime is another library using which I can import, let's say, datetime and even generate custom datetime as well. So from the datetime over here, I'm importing datetime and time delta. Time delta is essentially used to, let's say, apply calculations like addition, subtraction onto the datetime data. So this is what we have. These are the libraries needed. What is my prerequisite? My prerequisite is to set up the folders, right? This is my prerequisite. So just observe how we are setting up the folders. Now input directory would be stock input. So this would be the folder that I shall be creating. And the output directory is stock output. This is where all the output files will be stored, right? So input directory means used to save all the input files in this folder. And what about output directory? This will be used to save all the output files in this folder. All right, this is the input directory. Then we have the output directory. So over here we are using a function make dirs, which is make directory. So I'll be creating this directory as in the folder, input directory if it doesn't exist. All right, so exist OK is equal to true means it will be creating the folder if it doesn't exist. And make directory is again output directory. I'll be creating this folder. All right, if it does not exist in the first place. So this is the prerequisite. So currently, if you observe, we are in module 5.6. There is no other folder over here, right? So once I run this, once I execute this over here, we'll be seeing two folders, stock input and stock output. Let's run this. So guys, as you can see, this has been executed. If we go over here, we can find two folders. We have stock input and stock output, and they were created seconds ago. These files were not present previously. These folders were not present previously. We have just created them. All right, and both are completely empty. Currently, in दोनों folders में कोई भी data नहीं है. So the first step we have completed. Now let's understand the second step. I'll change the numbering. Let's understand what are we going to do. The second step is to generate sample stock CSV files. All right, the objective over here is to create a function that takes number of files. So suppose we want to create 5 files, 10 files, 2 files, 3 files. So this is the number of files. Tickers is the name of the stock as arguments. So we have to pass the number of files and the tickers as arguments and add the following functionalities. What are the functionalities? Generate synthetic open, high, low, close, volume and stock date for each of the ticker for a specified date range. So यहाँ पे अगर हमने 3 tickers pass किए हैं, so for each of these 3 tickers, maybe for n number of different dates, these files will be created. We have to inject some errors so that we can proceed with, let's say, data cleaning and pre-processing. So we'll be injecting some errors as well, and then we have to save the file to a specified path. Table का structure हम कुछ इस type से consider कर सकते हैं, where stock is, let's say, maybe the table name, or maybe we can customize it with date. All right, stock with maybe custom date. So custom date, we don't have to write this as a string, right? Rather, this would be injected as some date value. For instance, this would be something like this, maybe stock for 2025 All right, then maybe 01 and 20250117, something like this, .csv. As an example, we can consider this. This would be the file name. All right, this is going to be the file name. Clear? So this is a stock custom date, ticker, then open, close, high, low, and volume. This is how the, let's say, file will be created. So because the date is attached with the file name, so means this entire data was, let's say, captured for a particular date. All right, so let's see this in action. So over here I'm creating the file, right? So the function name is generate stock files, and the number of files that I'm using is 3. And what are the different tickers that I've used? I'm using Apple, then Google, and then Amazon. So these are the tickers that I'm using. Maybe if you want Indian names, so let's consider Infosys. All right, then I'm considering maybe Wipro, and then I'm considering let's say over here I'm considering Vedanta. All right, so these are the stocks that I'm considering: Infosys, Wipro, and Vedanta. Now the base date is datetime.today. So datetime.today returns today's date. Let's check. It is returning today's date, right? Now np.random seed, this is used to set the random customization. For I in range number of files, how many files have I considered? I have considered 3 files. So I is going to take value 0, 1, and 2. These are the 3 files. These are the 3 values that I is going to take. Now what is the file date? File date is base date minus time delta days I dot str f time. Let's understand this. Now I want to create let's say custom dates. So maybe for the past 3 dates I want to save the file names. So we have seen what is file date, right? Now time delta days I. So I, as we have seen, would take 3 values, 0, 1, and 2. So if I is maybe 1, if I is 1, if I don't pass this, what is file date returning? File date is returning this. Now if I'm using strf time, this is used to transform the date into a particular string format. So let's see this now. So this is 2025 522. All right, now if I pass day as 0, so this is current date, means barely we are subtracting anything. Then if it is 2, so then 2 days back. So maybe I want to capture past maybe 3 days data. So this is going to be the file date. Then the data that I'm using over here is, first I'm using ticker, and ticker is a name. So it can be any name from this list of tickers. So np.random.choice, I'll be passing the stickers, which is used as the function argument, and the size that I'm setting is 50. Then open values, so np.random.uniform, I'm using randomly, let's say uniform random distribution, and the minimum value that it takes is 100, maximum is 200, and it takes 50 values. Closing values, again np.random.uniform, 100, 200, and 50. And high is again np.random.uniform, 100, 210, and 50. So in high, I've raised the stakes. It can go maximum up to 210, and for low, np.random.uniform, I've set the lower limit, right? The lower limit is 100, the upper limit is 200, and the size is 50. So this would become low value, this would become the high value, right? Means this is the maximum that I'm expecting it to grow on a particular date. Then volume is np.random.random integer. So this is let's say 100k to 1000k. This is the volume range that I've set, and the sample size is 30. So this is my data. Currently this is a dictionary. So if I pass this into pd.data frame, this becomes a data frame, right? So these are the 5 columns that we wanted to create. If you observe this, the requirement ticker, open, close, high, low, and volume, 6 columns in fact. So do we have 6 columns? Yes, we have ticker. Then यहाँ पे हमने open use किया है, close we have used, high का भी data है हमारे पास, low का भी data है, and then we do have the volume. Next data frame हमने save कर लिया. Now it's time to inject some errors. Why are we injecting the errors? So that we can apply some, let's say, cleaning, pre-processing, transformation metrics and steps. So errors inject करने के लिए maybe in one of the files, in I is equal to 0. I is equal to 0 means in one of the files, let's say at a particular index 5, I'm setting the closing value as -100. That would be invalid. and at a particular index 10 I'm setting the volume as NaN. NaN implies null value, right? So this is invalid price. Stock price cannot be negative, so this is invalid price, and this is null value. All right, so this is the let's say errors that I'm injecting. Then I need to save this file, this data frame to some file path, right? So over here I'm using the file path as os.path.join input directory and then stocks file date.csv. So the first file date would be stocks underscore file date. So as we have seen at I0, what are we going to get? At I0, the file name would be, it would be something like this, stocks and then 20250503. This is how the file would look like. All right, and I'm storing it as a CSV. Let's understand what this os.path.join input directory and this represents. So suppose this is input directory that we have over here is, we do have stock input, right? And stock input is already created. Now in this input directory, suppose I'm creating a file abc.csv. All right, I'm simply creating an empty CSV file. So if I execute this, clearly we can see that this file has been created. So let's head over here. Okay, so means this currently, because we don't have any data, so it's not showing. So this is how, let's say, the input os.path.join, in this input directory this abc.csv file would be created. All right, because we have used this let's say folder a second ago, so this is what it was showing. So input directory was stock input, right? So guys, in this first function we have created this data for n number of files, for let's say 3 files that I wish to create, and then I'm saving the file to this file path, and then this is just the file path, right? This is just the file path. Now to save the file over here, I need to mention this. Let's call this file path. All right, now in this file path, ds.csv file path. All right, so we don't have a data frame defined. Currently we don't have a data frame defined, right? So this is how first I'm establishing the path. This is simply the path, and then onto this path I'm, let's say, saving some CSV file. So this is how, let's say, the file input output works. And then over here I'm simply printing generated the file path, right? So as we can see, the file path would be generated once I execute this function and call the function. So the first function we have created successfully. Now what is the objective of the second function? The objective over here is to create a function that takes file path as argument and add the following functionalities. First we have to read the file, then clean the data. We have to remove let's say rows with invalid prices, then find daily return percentage, find volatility, save file to the output path. These are our requirements, right? So over here I'm writing def process stock file. I need to pass the file path. Df is pd.read csv file path. So the first step is reading the file. All right, this was the first step. The second step is to clean the data. So we have to remove rows with invalid prices or missing volume. So over here I'm setting up the closing price greater than 0 because we have injected some let's say invalid price for the closing price. So I've handled this, and also I'm setting volume has to be not NA. Not NA means not null. So I've used all the, let's say, volume values where we don't have any null values, right? Then the third step is to compute the metrics. So what are the metrics I need to compute? Daily return percentage and the volatility. So daily return percentage would be df close minus open, closing price minus opening price upon opening price into 100. So suppose the stock price is closing at 500 and it opened at maybe 480, right? So it would be 500 minus 480 upon 480. So this would be the percentage change into 100 because I want to represent it as percentage. Now volatility is high minus low upon open into 100. So this is the volatility percentage, right? The maximum value that the stock price reached on a particular date minus the lowest value that it has reached on a particular date upon opening value. And then this entire let's say numerator upon denominator I'm multiplying it with 100 because I want to compute volatility percentage. Next I'm saving let's say we have to save, clean and the enriched version. So this is the fourth step. The fourth step was to save the file to the output path. So file name is os.path base name. This is the file path. The output path is os.path.join output directory, and I'm calling it processed file name. Alright, so this file name would be added over here after the output directory. Then I'm saving it to the CSV file df.toCSV, output path and index is false. Then over here I can simply print processed and saved. Alright, next I'm calling it processed and saved, and I'll be printing this output path. So if the function executes successfully, all these 4 steps should be implemented and this print statement should be displayed. Likewise, if this function gets executed, this is generate stock files. If this function gets executed, the file should be saved to the input directory, and it should generate this print statement generated the file path. So I should get to see this print statement indicating that the function has been executed successfully. So guys, ये दो steps हमने implement कर लिए हैं. The third step is to automate the input output loop, because there would be multiple files generated, right? How many files are we generating? 3. So for each of these 3 files, I need to apply this function. Alright, this function has to be applied. So this is where automation comes into picture. So this can be implemented using the OS module that we have imported over here. So let's see this in action. So the third step would be to automate input output loop. So we are going to create a function that takes file path as argument and add the following functionalities. What are the functionalities? We have to iterate through all the files from the input directory, and then we have to apply the process stock file function to each of these files. Alright, let's see how this can be done. So over here I'm writing def automate stock processing, and then for file in os.list directory input directory. Alright, os.list directory input directory, in each of the files which is present in the input directory. So the variable file would contain the file names. So if file is ending with CSV, is the file ending with CSV? Yes, over here we have said this has CSV. So this is a check. Let's say this is where I'm checking if the file is ending with CSV. So most likely it's going to be the stock underscore file date.csv. So if the file is ending with CSV, then file path, this is the file path os.path join. In the input directory, I'm reading the file name, and on this file name, what is the function that I'm applying? I'm applying process stock file, and then the file path I'm passing, right? So this function would be applied to the file path, irrespective of the number of files or the file, maybe one particular file. This function will be applied to each and every file present in this input directory if it ends with CSV. That is the only check that we have used over here. Alright, so let's execute these functions one by one. So this is the first function, right? This is the first function that we have, let's say, executed. Second function we have executed, not called yet. This is the third function which automates the stock processing, right? So I've called this as well. Now the fourth function would be to call above created functions inside the main function. So objective over here is to, over here the objective is to create a main function, call the generate stock file functions that is going to, let's say, generate the synthetic data, and next call the data automate stock processing function. So I need to call these functions one by one. Currently I've just, let's say, created the function, we haven't called them yet. So I'm using the main function generate stock files. This is going to generate synthetic data. All right, and what is this automate stock processing going to do? This is going to automate the data cleaning and metrics calculation, metrics computation on each of the, let's say, stock data file created. It is going to automate the data cleaning and metrics computation on each of the stock, let's say, data file created. So because this automate stock processing is calling the process stock file, all right. So automate the, let's call this function process stock file function. Automate the process stock file, let's say, functionality on each of the stock data file created. So these are the 2 steps, and this is what we are implementing. So let's write this over here. This is the first step. and then we do have the second step. This is my second step, right? So these are the two steps that we have. Now this is where the function ends. Next I'm calling the main function. This is how the function I've defined, and then I'm calling the main function. So let's run this. So over here it says the input stock input contains stock 2025 05 23, stock 2025 05 22, and stocks 2025 05 21. So these are the three files that we have generated and then processed and saved. So in the stock output we have processed stock 2025 05 21, 2025 05 22, and let's say 2025 05 023, right? So this is how the files have been stored. So if we check them in the stock input, as we can see, these three files are created, and in the stock output we can see again these three files are created, right? So if I want to read one of the files, let's see what the input file is all about. So this is maybe stock file 1. Let's call this sf1. This would be pd dot read csv, and this is the file name, right? So sf1 dot head. So guys, as we can see, these are the different values, right? These are the different values that we have. Next, if I want to see the processed stock, so this is processed stock file 1. This would be pd dot read csv, and this is the file name, right? So this is psf1 dot head. So it's not directly available, it is present in the stock output folder. So I have to pass the complete path. So guys, as we can see, this is the ticker. This is opening price, closing price, high, low, volume, daily return percentage, and volatility. So all the metrics means this data is cleansed. This might not be. So if I check in SF1, in SF1 dot let's say describe. So in closing, see clearly we are getting the negative values, and in volume maybe couple of values may be null. Let's check this. SF1 dot is null dot sum. All right, so we have null values. So clearly over here the data contains data is inconsistent, data contains null values. But is it the case with psf1? Psf1 dot is null dot sum. So clearly we don't have any null values, and if I apply describe, so clearly there are no negative values, right? As in, as far as these metrics are concerned, open, high, low, close, and volume, we don't have any negative values. So guys, this is how we have implemented stock price processing, stock price file processing automation using the file input output. So guys, that brings us to the end of this session. So let's switch to the PPT. So guys, in this session we have discussed how to automate file input output using NumPy and Pandas. So in the next session we'll be proceeding with batch processing systems, batch processing, and looped tasks. Thank you.